We talk constantly about how AI models are getting smarter, better at reasoning, better at generating content. But there's this persistent, really fundamental challenge that holds them back from being truly effective in the real world. And that's isolation.
It's a huge paradox, isn't it? This
Yeah.
paradox of power. You have these incredibly powerful, highly capable intelligence engines, but they're often stuck inside this digital fortress. They might know everything from their training data, but they can't see the file you just saved to your desktop or what's in your company's database or, the latest price list sitting behind some external API.
And that's exactly our mission today. We were doing a deep dive into the Model Context Protocol, or MCP. We're looking at an architectural overview of a system that's designed to solve that exact problem. Our sources lay out how this standardized system acts as a secure, efficient translator, building a bridge between that isolated AI and the messy real world.
Yeah, and what's really critical to get right up front is the core problem that MCP is trying to solve. So imagine you're building an app where an AI host large language model needs to do something complex. That task might need it to pull data from a SQL database, then maybe call a function on a REST API, and finally read some context from a PDF.
Okay, so that's three completely different ways of communicating, right?
Yeah.
One for the structured data, one for the service, and another for the file system.
Exactly. Each of those external systems speaks a different native language. And historically, if your AI wanted to talk to all three, you had to write custom, highly specialized code for each one. It's just a recipe for chaos, maintenance headaches, security issues. The AI and the data sources need one single, common, standardized protocol to interact reliably, and that common language is the Model Context Protocol.
So it's like the universal travel adapter for the AI's requests. It turns what sounds like a nightmare of custom connectors into one single structured conversation. That makes a ton of sense from a developer's point of view.
It just standardizes the friction points. It lets developers focus on the model's intelligence, not the integration complexity.
To really get how this works, we have to look at the architecture itself. The four key players involved in every single request. These are the four pillars of the system: the AI host, the MCP client, the MCP server, and then the data sources.
Right, and we start where all the action begins, the AI host. Think of this as the actual brain. It's where the model runs, and it's the driver of the whole system. It kicks off every single request when it realizes, hey, I need external data to answer this.
And we're not talking abstract stuff here. The sources specifically mention real-world platforms, like an AI host could be running on Claude, ChatGPT, or Cursor. That's the intelligence deciding what it needs.
That's right. But the brain doesn't speak the standardized protocol yet. It speaks AIEs, if you will,
Yeah.
which brings us right to our second player, the MCP client. Now, this is a really crucial point. The client lives inside the AI host. It's basically software that's embedded within that model's environment.
Okay, so if the AI says, I need the capital of the Netherlands from our latest internal doc, the client is what intercepts that raw thought. And its main job is something called request translation. So turning that thought into the standard MCP format before it goes anywhere.
It's the internal communications officer. It makes sure the dialect is standardized before sending the message downstream. This is so important because it decouples the AI's internal logic from all the messy formats of the outside world.
But wait a second, if the client is already translating the request, why do we need the server? Why add another layer? I mean, doesn't putting both a client and a server in between the AI and the data just add latency? Doesn't it slow things down?
That is a fantastic question, and it gets right to the heart of why the MCP server is so valuable. And yes, while it does add a layer, the trade-off you get in flexibility, security, and especially orchestration power is well, it far outweighs any minimal latency. The MCP server is our central intermediary. So if the client is the translator, the server is the traffic controller, the diplomat, and the execution engine all in one.
I like that diplomat analogy. So the server sits in the middle, and its job is execution and data orchestration. Takes that standard request it just got and figures out what to do with it. It knows what system to talk to and, more importantly, how to talk to it in its own language.
Absolutely. That diplomat role is key. The server is often managing things like API rate limits or handling security and authentication for databases. It's really the control plane for all data access.
And that brings us to the final component, the external world itself. The data sources. This is all the stuff the AI is trying to learn from.
And the sources break these down into three main groups, which really shows the breadth of what the AI can now get to. First, we have files, which they label as documents and assets. So, PDFs, Word docs, spreadsheets, any file the AI needs to read.
Okay, then there are databases which they call structured data. This is where the AI might need to, say, query a specific table or get some structured records.
And critically, we have APIs labeled external services. These could be third-party tools, internal systems, anything the AI needs to call to actually do something.
Right.
Without MCP, trying to talk to those three different things, a file, a database, and an API, would need three different, really complex, custom-coded connections.
So yeah, we've moved from this chaotic request environment to a really structured one just by adding the client and server. It really clicks, though, when you see them all communicating. Let's trace a request from start to finish.
Let's do it. Picture the whole flow, this seamless 5-step sequence that happens in like milliseconds. We start with the outbound journey, so steps 1 and 2.
Step 1 is just request initiation. The AI host realizes, I can't do this alone. I need some external context, and it fires off the request.
Instantly. And then step 2 kicks in, client translation. The MCP client, living right there in the AI environment, grabs that request and translates it into the precise, standardized MCP format. It's not getting the data yet, it's just standardizing the language and shipping it off to the MCP server.
Okay, so now the action moves to that central layer for the real core of the process. Step 3, data retrieval and execution. This is where that MCP server earns its title as the orchestrator, right?
This is where the magic happens. The server gets that standardized request, and it actively communicates with the right external data source. And this step is actually incredibly complex under the hood. The server has to interpret the request and then translate it again into the native language of the source. If the AI needed data, the server runs the SQL query. If it needed a PDF, it reads the file. If it needed a service, it makes the API call. It does the native command and gathers the result.
That is the heavy lifting. The server is juggling the native language of the outside world database syntax, API structure, whatever, and pulling back just the information that's needed. Once that's all packaged up, we start the journey back, steps 4 and 5.
Right. Step 4 is return data. The fresh, relevant info travels back through the MCP server and then back through the MCP client. The client's role on the way back is often just verification, handing the data off to the model in a way it can understand.
And finally, step 5, AI response. The AI host gets this specific processed context. It takes that information, the capital of the Netherlands, from the doc, for instance, and uses it to generate the final, informed, accurate response the user was waiting for.
And the beauty of it is that the AI model never has to learn how the data was retrieved. It never knows which database was queried or what the API endpoint was. It just asks in the standard language and the system delivers. It completely abstracts away all that complexity of external access, which used to be the biggest bottleneck in building real-world AI apps.
Which brings us perfectly to the why you should care moment, because this architecture, it isn't just about elegant engineering. It directly leads to more powerful, more reliable AI applications for us, the end users.
Exactly. When you abstract away that integration complexity, you unlock so much potential. And when we look at the benefits summary in the sources, 4 key things just jump out, and they all stem from that central idea of standardization.
Let's start with the big one, standardization. It's more than just consistent communication. I mean, think about maintenance. In a non-standard world, every time a database schema changes or an API gets updated, you might have to rewrite dozens of custom connectors.
Ugh, yeah. But with MCP, the language between the AI host and the server stays the same, no matter what changes on the outside. The only thing that needs an update is the server's specific connector for that one data source. It dramatically reduces the maintenance burden.
That leads right into the next benefit, scalability. Adding a new data source used to mean weeks of integration work, testing, security checks, a huge drag on growth.
Because the protocol is consistent, adding new tools is less about building a brand new bridge and more about just plugging into the existing architecture. It means developers can expand the model's reach smoothly. You could add hundreds of data sources without a proportional increase in complexity. That is a massive unlock for any big company.
And then there's seamless integration. This speaks to how it connects those totally different systems, the PDF reader, the SQL client, the API caller, so robustly.
Yeah, the MCP layer handles all the protocol conversions. It translates the AI request into a database query and then translates the result back into an MCP context object. It manages that two-way conversion, making the whole thing feel simple, even though the mechanics underneath are really complex.
Right. And finally, there's flexibility, because the architecture supports files, databases, and APIs, or as they're termed, documents and assets, structured data, and external services.
It means the AI gets access across this genuinely diverse set of data types, It's not locked into one format. An AI could, in a single session, process a spreadsheet, then check a customer record in a database, and then place an order via an API, all seamlessly. That level of flexibility is what turns AI from a powerful calculator into a genuine operational tool.
So if we pull back and synthesize all this, the Model Context Protocol is really that indispensable middle layer. It's the translator that standardizes requests from the AI, and it's the orchestrator that retrieves context from the wild, diverse world of external data.
By creating this standardized protocol and that specialized intermediary layer, MCP enables AI applications that are just exponentially more powerful, more scalable, and more flexible than isolated models could ever hope to be. It's the essential step to moving AI from theoretical power to applied utility in the real world.
That was a detailed deep dive into the Model Context Protocol architecture, focusing on the 4 components and that critical 5-step flow from request to response. We saw that MCP streamlined how AI systems talk to every kind of external context, a document, a database, a third-party service.
It's that secure, indispensable middle layer. It translates requests and orchestrates data retrieval between the AI brain, like a ChatGPT or Claude, and the huge, messy outside world of data. But let's leave you with a thought to mull over. The MCP standardizes how AI accesses external context.
Which raises a really important question for the future, right? If we can standardize communication for data retrieval, what new innovation is unlocked when this lets AI models not just retrieve information, but actually integrate execution across multiple external services at the same time?
Think about the friction that eliminates. Imagine an AI completing a multi-stage task, something like analyzing inventory from a database, ordering new parts through one API, and then updating a fulfillment tracker through a second API. All of that using a single, unified, standardized execution instruction flowing right through that MCP server. It suggests a future where the friction between intelligence and action is basically zero.
It's a complete evolution in how we think about AI integration, the complexity of building systems that can operate in the real world, juggling all those languages. It's now being abstracted away by protocols like this. That standardization of execution, that's truly the next horizon.
Absolutely. The foundations are being laid right now.
Thanks for joining us for this deep dive.